Assalamu alaikum wa rahmatullahi wa barakatuh. Good morning, everyone. Today, inshallah, I will continue with you the sessions or the bunch of sessions for the referrals and the referral for mathematics 2. This session is dedicated for all of you who have some problems in differentiation and integrations. We will go through the main rules, how to apply them, how to solve them and get the best of your results and the best on your exams, and how to be a holder for your markings. Okay, of course this is mathematics 2, this is from the IB team who's working with you in the referral sessions. All of our course notes references, you will find it on Canvas, plus all the recorded sessions, you can find them on the YouTube channel that's related to you, as I told you previously. Okay, this is the main course and the distribution on the various weeks according to the SMP schedule. I will talk today about differentiation and integration, the last two topics in your syllabus for this semester. Once more, you can go easily to the YouTube channel, Dr.Omar. Just go straight forward to playlists, choose the suitable playlist for you, which is simply UHIV Math 2. You will find all the course recorded sessions that's previously on SMP. You will find them, all of them here, covering all the topics that we did go through. Plus, you will also have the referral sessions that we started to record starting from the previous week. Okay. Today I would like to go through derivatives with you. I will make a short session for you just to concentrate on the main laws, how to apply them, how to get the best of your marks today. As I told you previously, this session is just to a shortcut for the main laws, how to apply them, how to get the best of your results in differentiation, and also I will go through integration. This session is not a replacement from the main vid that you can find on the same playlist that I told you previously. But it's a continuation for it and the summary of the main laws, so you can go through them, then solve, please, all the solved problems that exist on your main slides, and you will find them on Canvas. And also, you can retry these problems, try to solve them by yourself, use your skills, try to think and listen carefully. As I told you previously, this is the introduction for the direct derivative laws. It's really very nice, very easy to go through. Remember that derivatives can only be distributed on solid difference. That's a main law. If you have some problems connected together, you can simply find their derivative straightforward by differentiating each part of your problem, as we will see. Remember in all times that derivative cannot be distributed on multiplication or division. That's a main law. Each one of them, they will have a separate law. For multiplication, for the functions that are multiplied in themselves, or for the division of various functions. You will have to follow their laws. This is the main laws that we will depend on them. I will write you a bunch of laws, but it mainly depend on these main formulas. First of all, a derivative of a constant equals 0. That's if you have y equal 10, if you have y like equal 15 or something, then the derivative will be simply 0. If you have y equal to x, so simply y dash will equal to 1. If you have y equal to c times x, which is the dependent variable in your derivative, it's simply y dash is going to equal to c. Like if you have y equal to 7x, y equal to 10x, something like this, so y dash simply will be 7, will be 10, which is the constant value that's multiplied by x. If you have y equal x to the power of n, then simply y dash is gonna be, we will do 2 steps, don't you forget, just only 2 steps. We will move the power to be a multiplication in the main function, plus taking 1 from the old power. So if you have x to the power of n, y dash simply is going to be n times x to the power of n minus 1. So actually we do 2 things. We do multiplication, then subtraction from the power. Subtract 1 from the power. Whatever the power if it was an integer, fraction, or whatever. So simply if you have y equal x to the power of 4, y dash is going to be 4 times x to the power of 3. So if you have x to the power of 7, simply y dash is going to be 7 times x to the power of 6. You will find a lot of problems in the main session. If you have y equal 1 over x to the power of n, simply first, before you do your derivative, just move the power from the denominator to the numerator form, putting a negative sign to the power in the denominator. So if I have 1 over x to the power of n, first, let it be on the form x to the power of negative n. Then apply the previous rule. So it's going to be negative n times x to the power of negative n minus 1. So simply, if you have y equal 1 over x to the power of 2, it's going to be x to the power of negative 2. Then the derivative is going to be negative 2 times x to the power of negative 3. Don't you ever forget y equal ln x, which is an example of a arithmetic function, which is the natural logarithm. The derivative is really very simple. It's going to be 1 over x. So the derivative of ln x, simply, it's going to be 1 over x. This is really a very important law. With the previous two laws, it will complete all the types of powers that you may find in any problem. As I told you previously, if you have two functions added or subtracted from each other, then the derivative of these functions is going to be the derivative of the first function, plus or minus, according to the sign. We don't care about that. The other function derivative. So, simply, addition and subtraction in derivative. If you have two functions added or subtracted from each other, it will equal to the addition or subtraction of the derivatives separately. But if you have two functions multiplied in each other and you want to find y dash, simply it's going to be the derivative of the first function times the second plus vice versa. So it's going to be g dash times f plus g over x times f dash x. If you have two functions divided on each other, remember in all times, derivative cannot be distributed on division, as we spoke about this a lot of times previously. Simply, y dash is going to be, take the denominator to the power of 2, so it's going to be f of x to the power of 2, then start differentiating the numerator times the denominator minus vice versa. So it's going to be f of x to the power of 2, g dash times f minus g of x times f dash of x. This law is very, very important. Those are the main derivative formulas or laws. Plus, please note the following. I will try to write them down for you. This is the bottom line and the summary of all the derivative, fast derivative formulas that you can use. I will start with the first one of them. Remember, if I have y, which equal to f of x to the power of n, whatever f of x is, if it was a polynomial, if it was a trigonometric function, a arithmetic function, whatever, I don't care. So the derivative is going to be simply, this is the main law and this is really, very important. You will have to memorize it as it is one of the essential laws in integration that we will go through shortly, inshallah. So simply, y dash is going to equal to, make the power go down, so it's going to be n times f of x to the power of n minus 1. Then times the derivative of the function inside the bracket. Don't you ever forget that f of x you will have to differentiate based on the laws that we spoke about previously. This law is really a very important law and a critical law. So it's really very important. I will give an example on it, a small example here. The second law that I want you to remember at all times, once you have y equal to ln of an f of x. So its derivative is going to be exactly like we spoke previously. So remark, y dash will equal to 1 over f of x. What I did here is the derivative of the arithmetic function. But don't you forget, times f dash x. Simply, we can write it f dash x by f of x. This is the law for the arithmetic function. And this is really one of the important laws that we will depend on shortly on integration. So it's really very important to mark these two laws in front of your eyes in all times. Plus, if you have y equal to, we already did go through the power, Alan? Yes, the exponential function, you are right. If I have e to the power of f of x, the derivative is unique. And it's going to be like this. Y dash is going to equal to. This is an exponential function. So first of all, you will have to put it. So it's an e to the power of f of x times f dash x. So we do two things. First of all, just put e to the power of f of x as it is. Don't play with it. Just simply put it down. Plus, or I'm sorry, times the derivative of the power. Remark. In each one of these functions, we already did the derivative of the main function times the derivative of the function which inside this either a power or an arithmetic function or an exponential function. So in all times, remember, we write the main derivative times the derivative of the power of the main function that really exists. It exists here, same manner here, same for the other. Also, remember for all types of trigonometric functions, if y equal to sine, cosine, tan, whatever, for any of the trigonometric functions, let's say for example, if I have a sine for a function which is f of x, plenty of you make this mistake. If I have sine of a certain function, so simply, if I want to differentiate, get y dash, it's gonna equal to. Differentiate first the main function, the main trigonometric function, which is a sine, cos, tan, cot, sec, whatever. So I will try to differentiate sine, which is simply gonna be cosine of the angle, which is f of x. This is a cosine for an f of x. Don't you forget, times the derivative of the function, which is gonna be f dash of x. If I have cosine of f of x, then y dash is going to be simply negative sine, which is the derivative of a cosine function, times of an f of x times f dash x. These are the main laws, don't you ever forget them. Those are really very important laws. So, if I want to give you some examples just to illustrate how to use these laws, it's really very simple. If I want to differentiate, for example, for the first law, if I have y equal x squared plus 4x to the power of 5, for example, simple. If I want to differentiate, don't you forget, you will have three terms, don't forget that. So, simply y dash will equal to, just move the power, so it's going to be 5 times, take one of this bracket, so it's going to be 4 of x squared plus 4x, and don't ever forget the derivative of the function within the bracket. So it's going to be simply x squared, which is 2x, that's the derivative of x squared, plus 4, and voila, you are done. So you have x, a function to a power. I did three things. The power moved down. I subtracted 1 from the power, times the derivative of the function which is inside the bracket. Okay, once more, if I have y equal to len of any function you can think of, let's say x cubed plus 5. If I want to get y dash for this function, it's really very simple. All I have to do is to remember the window, then start differentiating. So it's going to be simply 1 over x cubed plus 5 times, don't you forget, the derivative of the function inside of the argument of the respective function. So it's going to be 3 over an x to the power of 4. So we can write it, if you like, write it in a simpler manner. So it's going to equal to 3 over x to the power of 2 divided by x cubed plus 5, which is simply the function in the denominator and its derivative assigned to the denominator. Okay, if I want to differentiate sine, an example for an exponential function. Okay, if I have y equal to e to whatever, let's say x 5x power 4 plus 3x squared. So its derivative mainly will be, once more, what the exponential function as it is. So it's an e to a power of 5x power 4 plus 3 over x squared times, start putting the derivative of this function, which is simply going to be 20 over x to the power of 3 plus 6 of x. You are done. Very simple. Just putting the exponential function times the derivative of its power. Okay, if I have a sine, cosine, whatever, if I have like y equal to a sine of an x squared plus 4x, for example, take care. Y dash is going to be equal to, first of all, get the derivative of the sine, which is simply going to be cosine. So it's a cosine. Cosine for whom? The same bracket, which is x squared plus 4s. And don't you forget, times the derivative of this angle, whatever it is. So it's going to be at 2x plus 4. I've differentiated this function. This is really very important. Very short, to the point, and it's very important to remember all of this. If I were in your shoes solving any of these problems, please try to write the main law correct, then start applying your law. This way, you will be in a safest position and a mark holder for each step of your steps down the road. So you are helping out your leader or whatever who's going to mark this exam for you. He will understand, you will help them to understand that you know the main law and how to apply it on this problem. This is very, very important in derivatives in general. Please do not hesitate to listen to the main session for the derivative, which includes the definition of derivative using first principle, the main law of derivative, and the increments, how to deal with them, the gradient, how to get it. Then a lot of problems, and I mean a lot of problems, really solved for you for how to apply these tools and the more in the main vid of derivatives. Okay, perfect. Once more, I will try to go through some problems to help you just a little bit. If you have any of these problems, it's going to be easy to go through any of them. I will choose one of them just to refresh your data. I will start with, let's say, problem number B. Looks interesting. Okay, let me go through them with you. Okay, I will do problem number B, which for some people looks complicated, but I don't see it that way. Then I will try to solve, let's say, problem number D, as it contains cosine and sine, and I will go through problem number E and F as fast as possible. Those problems, first of all, in order to get a successful solution for these problems, follow the coming steps. First of them, if I want to go through the problem which is number B. If I want to go through problem number B, let's say y equal to x minus 1 times x squared minus 2 over x divided by x to the power 4. If I want to go through this problem, I will have two ways in order to help me out in solving or dealing with this problem. One of them is try to get the multiplication or simplifying this bracket as much as possible. So, and the second one is just to apply the law of the derivative. I will choose, as in the previous session, I've dealt with this function directly using the derivative law. I will try to simplify it for you. It's really very easy. And remember, the law, you can write it like this. Y, which equal to G divided by F, Y dash is now equal to F to the power of 2, which is the denominator to the power of 2, get G dash times F minus beta G times F dash of X. That's a shortcut for what I'm going to do. If you just write this down, you will make me understand that you know the rules, So you know the main rule that you are going to apply it. So I'm going to focus with you more on what are you going to do. I will start writing y, which is simply going to be x squared times x, or multiply x in all these terms. So it's going to end up to x cubed, then x times negative 2x, so it's going to be negative 2x to the power of 2. Minus 1 times x squared, so this number is going to be negative 3. Negative 1 times negative 2x is going to be plus 2x. Please review these steps with me. Divided by x to the power of 4. I can simplify it a little bit if you like. So it's going to be, let's take x as a common from the denominator and remove it with one of the x's in the denominator. I'm trying to simplify first before differentiating, and it's simple. So it's going to be x cubed. So this one is going to be x and squared minus 3 over x plus 2. I will start now differentiating according to this law. Y dash will equal to. I will take x cubed, which is going to be x cubed to the power of 2. Then I will start differentiating the denominator, which is going to be 2 over x minus 3. I'm done with the derivative of the denominator. Then I will multiply it by the given denominator, which is x cubed, minus, I will do vice versa for these terms. I will try to move the denominator as it is. So it's going to be x squared minus 3 over x plus 2 times. Get the derivative of this function, which is going to be times 3 over x to the power of 2. I already did both units. If you got time, if you have time, start to simplify this form. If not, just go through your exam, then get back to this problem and try to simplify it as much as possible. Okay, perfect. This is problem number B, for example. If I want to go through problem number D, it's going to be exactly the same. So for problem number D, which is y equal to cosine of x divided by 1 minus sine of x. Getting y dash, it's very simple. All I have to do is to get the denominator to the power of 2, so it's 1 minus sine of x. Then start differentiating the denominator, whatever it is. So it's going to be negative of a sine x times the already given denominator, which is 1 minus sine of an x minus vice versa. I will start writing the denominator, which is cosine x, times the derivative of the denominator, which is going to be negative of cosine x. If you like to simplify it the way you like it. If not, just leave it as it is, and after you finish your exam, get back to it and start simplifying as much as possible. Okay, so this is mainly the main law, as you can see. I would like to go through, let's say, another problem, like some parts are added or subtracted to each other. Let's say, instead of solving E, I'll give you another problem, which is, let's say, y equal to 2 2e to the power of x squared minus 4x. Just then in a second. This is 2. Then plus ln over x squared minus 4x, then minus whatever sine of a root of an x plus 1, for example. I can do whatever you need. Okay, let's do something else. Plus 2 over x squared minus 4x. First of all, take a good look for your problem. Start, if there is something to simplify, just simplify it. Then start differentiating each part separately. It's like problem 1, problem 2, problem 3, and a fourth problem. So, see if I want to differentiate. First of all, I will go through the differentiation of the exponential function. So y dash equal to the main exponential function, which is e to the power of x squared minus 4x. This is the 2. I'm not going to do anything with it. The derivative of 2x minus 4x is going to be at 2 over x minus 4. I'm done with the exponential part. Then plus, I have the logarithmic function. So it's going to be simply 1 over x squared minus 4x times the derivative of this function, which is going to be 2x minus 4. then a minus for a sine, and something, or the argument of the sine function or the trigonometric function. So it's going to be negative of cosine of root x plus 1 times, don't you forget, the derivative of this function. I want to differentiate root over x plus 1, which simply can be put as x plus 1 to the power of half. The derivative of a bracket with a power is really very simple. As I told you, 3 terms. It's going to equal to a half over x plus 1 to the power of negative half times the derivative of the function inside, which is 1. So simply all I have to do here is to add 1 over 2 times x plus 1 to the power of negative half. This is the derivative of the argument, and this is essential. If I want to look to this problem, I can put it on this form: 2 over x squared minus 4x to the power of negative 1, which is going to be really very simple. All I have to do is to make a plus, then I will let the power go down, so it's going to be negative 2, negative 1 times 2, which is negative 2. Take 1 of the power, x squared minus 4x, subtract 1 from negative 1, so it's going to be negative 2, times 2 over x minus 2, which is the derivative of the function inside the bracket. This is a successful treatment for a long function. If he asks you to get a value of the function like this one at x equal or correct 2 decimal places, it's really simple. Start substituting, replacing every x here by 1 first, then try to evaluate it using your calculator. So let me see that you are replacing every x in whenever, whatever it is, by 1, then try to use your calculator in another step to get the values of these parts. So this way you are helping yourself to keep safe as much as possible, getting a mark for each part of these parts. I think that's it for the main laws and everything, so please do not hesitate to go through the main method of the derivative which already exists on the main session of this part on your own canvas, either the PowerPoint or the PDF for the slides, and also you will have a recorded vid, which, as I told you a lot of times previously on YouTube. Okay? Thank you. Okay, let's move to something else. I'm going to move now this problem exactly like the previous one. So all I have to do is to differentiate this part, plus the other one, the next one, and so on. Please try to solve this problem on your own. It's really very simple. I don't want to solve it with you. I would like you to try to solve it out as fast as possible. This is going to be 2 times x minus 1 to the power of negative 1. So derivative is going to be negative 2 x minus 1 to the power of negative 2. This one is going to be 2 over x plus 1. This part is going to be positive over 6x, positive 6, times e to the power of negative 3x. This is going to be 2 times cosine x, then plus sine over 2x, don't you forget, times 2. Try to solve it by your hand, please. Okay, I want to move to integration, which is the or the inverse process of what all we did go through. All I have to do into integration is to reverse the problem. I usually say that derivative, it's like driving your car forward. Integration, it's like moving your car back to its original position. Moving forward, then moving it backward to your original position. This is very, very important. Okay, as I told you, you will have this table and a lot of more of integration formulas in the main session of integration, so please do go through it before trying to go through this sample. If I want to integrate 1, so it's going to be x plus c. Remember, this is called indefinite integration. Why we call it indefinite integration? Because simply the integration sign doesn't have integration limits. There is no numbers above the integration sign. So 1 is going to be x, but we have to, in indefinite integration, to add a constant. And this is a derivative issue, and you will have the explanation on the video. So in all indefinite integrations, after you integrate, you will have to add a constant. If you didn't add a constant in indefinite integration, you will lose at least half a mark for this, because it's really very essential. The second rule is, if I want to integrate b, if I have 3, I want to integrate. If I have -4, I want to integrate. Simply, I is going to be, if I have 2, so it's going to be 2x. Don't you forget the c. You have a lot of problems or anticipative examples beside this rule. 3 is going to be 3x plus c, -5, it's going to be -5x plus c. If I have 3 over 2, so it's going to be 3 over 2 times x plus c. Okay, if I have b times x, if I have 2x, 3x, 4x, -5x, 5 over 2 times x, the integration simply will be, I will reverse the differentiation process. In differentiation, if I have x to a power, I usually do addition, then subtraction from the power. In integration, I will move backward. So I will start by adding 1 on the power of x, then I will do division. So integrating x to the power of 1, it's going to be first x to the power of 2, then divide on the new power. So it's going to be x to the power of 2 divided by 2, then add new constants. You have a lot of illustrative examples here. If I have x, so it's going to be simply x to the power of 2 divided by 2. Don't you forget, it was a constant. If I have 5 of x, so it's going to be simply 5 times x to the power of 2 divided by 2, plus a constant, and so on. The main rule for this part is, if I have x to a power of n, all the powers, whatever it is, integers, negative numbers, fractions, whatever, will follow this rule. You will add 1 on the existing power, then divide on the new power. Except if the power equal to -1. And this is obvious. If the power is -1, once you add 1, it's going to be x to the power of 0. And then you will make a division with 0. So it's a nonsense. So don't do it. All the powers will be treated this way, except if you have x to a power of -1. It's not going to be treated this way. Okay, if I have x squared, simply, it's going to be x cubed over 3. If I have x to the power of 3, so it's going to be x power 4 divided by 4. I do addition first, then division on the new power. If I have x to the power of 4, so it's going to be x to the power of 5 divided by 5. Whatever the numbers that exist outside the integration or in front of the number, you would just add it and simplify. This also goes if you have dx over x to the power of n. First, make it x to the power of -n. Then start adding 1 on the power and dividing on the new power. As you can see, if I have 1 over x cubed, so it's going to be x to the power of -3, add 1, -3 plus 1 divided by the new power. I will give some examples, shorter. If I have b over x, I want to integrate. This is a power of -1, so simply it's going to be a logarithmic function. Let me do some examples for you. Okay? Let's say, if I want to integrate, for example, x to the power of 4 plus 3 over x to the power of 2 plus 5 over x to the power of 2 minus, let's say, 3 over x plus a 5 with respect to dx. So I'm integrating all these parts with respect to x. It's like assembly of all of these functions separate, and I'm going to integrate each one of them. So let's start with the first one. This is indefinite integration. As you can see, there is no integration limits. So simply I, it's going to equal to x to the power of 4. I will start first adding 1 on the power. So it's going to be x to the power of 5. Then I will divide by the new power. If I want to go for the second problem, similar manner, it's going to be simply plus a 3 times x to the power of 3, then divided by 3. If I go to the other part of this problem, which is going to be plus, first of all, try to adjust to this function. So I'm going to write it like 5 times x to the power of negative 2. Applying same rule. So simply it's going to be a 5 times x, add 1 on the existing power. Negative 2 plus 1, it's going to be negative 1. Divided by the new power, which is negative 1. If I have negative 3 over x, careful, this is x to the power of 1. So if you raise it up, it's going to be x to the power of negative 1. I can't use this term. This function is the logarithmic function. So it's going to be negative, I'm sorry, just a second. So it's going to be negative 3 ln x. Then plus, this is a constant number. In integration, it's a b, so its integration is going to be b of x. So it's going to be 5x. Don't ever forget plus a constant. Some of you would say each one of these functions, once you integrate, you can add a constant number. I'm gathering all these constant numbers, those numbers that I don't know actually, if it was positive, negative, whatever. So I'm collecting them all in one constant, as you see. That's the main application of this rules on these types of integration rules. Really very simple, but you have to understand them. And all of them, we have these rules from inverting the derivative rules that we applied previously or by the beginning of our session today. Okay, perfect. Okay. Of course, a fraction function will be treated exactly the same. So I have 3 times root of an x. It's going to be simply 3 times x to the power of half. So integrating it, it's an easy process. All I have to do is 3 times x to the power of 3 over 2 divided by 3 over 2 plus a constant. It's very simple. Okay. This is a form that's stressing on the fact that integration only distributed on addition or subtraction. Those are some of the rules that I want to go through them with you. I will try to write them down for you here, and then I will